Yeah, so this is a image that always tickles my funny bone when I see it, because I get the impression that there will be a big tarp over this thing that will magically open up at 8 a.m., which would be a pretty enormous tarp to begin with. The meteorite, and we have a piece of it here called Canyon Diablo. Canyon Diablo is actually this winding arroyo back here, but that's the name of the meteorite that comes from this crater near Winslow, Arizona. It's about 3/4 of a mile wide and about 600 feet deep. It was caused in an impact about 50,000 years ago. And the impactor was a iron metallic piece of asteroid that is about half the size of a football field. Most of it evaporated due to the heat of the impact, and small spherules were found nearby. But there are also a lot of fragments that were found as well. And so this happens to be one of them. So it's one of the things that the attendees here can see and touch. But to give you a sense of the idea, the little black spot at about 1 o'clock there is the parking lot of the visitor center. That gives you a sense of the scale there. And then you can see the road leading up to the visitor center. So the agenda for today is I'll talk a bit about backstory, a bit about meteorite basics, run through some meteorite relatives, things that are related to meteorites, talk about acquiring meteorites should you have a desire to do so, and using meteorites for outreach, which is something I like to do. And finally, some FAQs, frequently asked and hopefully answered questions. So it started with a gift when I was leaving Connecticut and moving to Virginia. I got a going away gift of a nice, well, now know it's a palisade, a nice meteorite. In fact, it was so nice, I was wondering if they wanted me to stay away, But anyway, so it started with a gift. And then after a couple of years, I received a couple more as gifts. And then it hit me. This is going to be great stuff for Cloudy Day Astronomy Outreach. And so I started to then acquire meteorites and started to collect them and then take them to events such as Astronomy Day and Stargaze and that sort of thing. So, and now my collection is over 430, by the way. I'm going to cover some basic terminology, some basics of meteoritics, the study of meteorites. So a meteoroid is a small solar system body, something like an asteroid, but say less than a few meters in size. Meteor, of course, is a meteoroid that enters the Earth's atmosphere and glows. People like to call them falling stars or shooting stars, but meteor is the correct term. And of course, if you have bright ones, they can be called fireballs or bolides and that sort of thing. And a meteorite is actually a meteoroid or a piece of a meteoroid that survives the trip through the atmosphere and hopefully is found. And a nice little animated GIF file that will show the difference. So one or more meteorites discovered as a result of a witnessed or documented impact event is called a fall. And that's as opposed to the find, which means that you found something that wasn't associated with a known or witnessed event. That happens to be, the top image is one of the dash cam, which you can find all over YouTube from the Chelyabinsk fall back on near Valentine's Day on 2013. And so that was a very famous fall. I have a piece of that here on the table. What I don't have is a piece of the bottom one, which is called Poba. That happens to be the largest known single meteorite piece. And that's because that's mostly still in the ground in Namibia, where it's sort of a national treasure. And the number of finds vastly outweighs the number of falls. Most meteorites are named by the closest geographic entity to where they were found. So it could be a town, county, or a geographic feature. And if there are multiple unrelated meteorites that are found in the same locale, then usually you'll see a number or a letter in parentheses or some other designation appended to the name. And the number can contain the year of discovery in certain Sahara meteorites and in most Antarctic meteorites. Now, the earliest witnessed fall in what we call the Western world with preserved pieces was in 1492 in Alsace, a place called Ensisheim. Got a small piece of that here as well. And that was a stony meteorite, by the way. So in 1803, a French scientist was sent to analyze a recent fall in France near a place called L'Aigle, the Eagle. And he brought with him a piece of a previous fall called Barbitan, which is the one on the left. And he interviewed all sorts of people from all walks of life and found that they told similar stories about the witnessed fall. And he gathered up pieces and found where they were located, what we call a strewn field. And he concluded that meteorites did come from outer space. Because previous to that, there was doubt among the, what you call then the scientific community, the natural philosophers then, that they weren't really convinced that meteorites came from outer space. But he wrote up a nice report. I have an English translation of that here. And his report convinced the scientific community that meteorites were indeed extraterrestrial. And so one of the things I always mention when I talk to especially young people is that one of the important things about doing science is not only making discoveries, but being able to communicate those discoveries effectively. So the first recorded fall in the United States, which was then a new country, occurred in Weston, Connecticut on December 14th, 1807. And you'll find a piece of Weston here on the table as well. So let's talk about where these things come from. So most meteorites are pieces of asteroids. Now the rest were blasted off the moon or Mars, at least the surface of the moon or the surface of Mars. But most of them are pieces of asteroids, things from the asteroid belt in between Mars and Jupiter. So these asteroids are the remnants of planetesimals that formed in the early solar system. And larger planetesimals, like the Earth, experience internal heating due to a number of factors, including radioactive decay, gravitation, and impacts. And so these result in a process called differentiation, not the math type for you math people here, but the geologic type of differentiation, which means that the heavier stuff goes to the core and the lighter stuff floats on top. And that, believe it or not, can occur in about 100 million years. Seems like a long time, but geologically or cosmologically speaking, it's pretty quick. So, how do we classify these things? Well, make things a little more confusing, there are actually multiple classification systems. So the easiest one to talk about is the older one, which is the structural and physical appearance of the meteorites. And so it's easier to apply. And again, it's based on the external characteristics of the meteorites. More complicated is the chemical properties classification. That's the newer system. And what it is supposed to do is supposed to aid in grouping meteorites by the originating or parent body. But to make things even more confusing, hybrid classification schemes are common. So I'll talk about the simple classification. And so make that real easy. You've got stony meteorites, you've got iron meteorites, and a mixture of stony iron. And so for the first blush, that's really all you'll need to know. Now, stonies are the most common by far, making over 95% of all meteorites. And that number now is about 77,500 known meteorites. Now, most of the stony meteorites are what we call chondrites because they contain these things called chondrules. They're these small, generally small spherical inclusions, and they're round grains that are formed out of some of the very first things to solidify in our solar system. So they were solid when the Earth itself was still liquid. And so they're made out of mostly olivine and pyroxene, various silicates, and they're usually encased in some what we call felspathic material. So again, most meteorites that contain them are, well, the meteorites that contain them are called chondrites, and they are really technically meteorites that sort of mirror the non-volatile composition of the sun. Other meteorites are called achondrites, and these could be parts of differentiated asteroids and things that are come off of the surface of the moon or Mars. And so there goes a complicated pie chart to show you again, the types of percentages we're talking about here. So again, ordinary chondrites are by far the most common type of meteorite. And so, yeah, ordinary chondrites, those are most common. And so we, picked a very distinctive name, ordinary. We have some other types that are called carbonaceous. And believe it or not, some of them do contain carbonates, but most show signs of being altered by water. And so it's believed that these pieces of asteroids, or these asteroids that they came from, were found further out in the asteroid belt, closer to the Jupiter side, or past what you'd call the water line in the solar system. And then there's some other types which are quite a bit rarer, enstatites, rumerudeites, and very rare cacangariites. And so some of these meteorites, quaternary contracts, contain calcium aluminum rich inclusions, which are believed to be the very first things that were solidified in the solar nebula. The oldest is dated to be more than 4.5 billion years old. And so compared to Earth rocks, those are very old. The oldest Earth rock, and I have some that is represented here on the table, is from northern Canada, called Acasta gneiss, and that's about 4 billion years old. So these things are at least 500 million years older than that. They're usually light colored and irregular in shape, and so some chondrites contain CAIs. In terms of metallic, many meteorites, including stony meteorites, by the way, contain actual metal. And the metal used to be called siderite, but they're a mixture of iron and nickel. I'd like to ask kids how many know what this thing is. And under very slow cooling conditions, like a few degrees every million years, the iron-nickel core of an asteroid can develop crystal structures, crystal patterns, are known as Widmanstätten patterns or tungsten structures. And so these are features that really can't be duplicated here on Earth. They're kind of like snowflakes. No two are exactly alike. And you'll see some examples of that here on the table. And then there's stony iron meteorites. And so very beautiful ones are called pallasites. These are iron meteorites that have embedded olivine crystals. Olivine actually is a common mineral here on Earth too. And when it's gem quality here on Earth, we give it a fancy name. We call it peridot, the August birthstone. Now, pallasites are named after a scientist named Peter Pallas, who was the first to analyze one that was found in Russia in the mid 17 or later 1700s, I should say. And so these pallasites are arguably the most beautiful meteorites, and many of them are used for jewelry. The other type of stony iron meteorite is called the mesosiderite, and these are about half stone and half iron. Now, the newer classification uses chemical analysis to determine the proportions of some trace elements like gallium, germanium, and iridium in these iron meteorites to tease out ones that are related and may come from either the same parent body or family of parent bodies. And so there are about 4 groups and up to 7 subgroups and all that kind of stuff. So it gets pretty complex, and you can see it illustrated by these diagrams here as they do various sorts of cluster analyses to figure it out. And then even with that, about 15% of iron meteorites are still none of the above, so they're called ungrouped. And so the newer classification, since it tries to link meteorites to their parent bodies, they have, instead of going stony and stony iron, they say some are undifferentiated, some are differentiated, and then there's some that are partially differentiated, which are called primitive achondrites. So as I've heard said, nature is under no obligation to make this stuff easy for us to understand. So that is a very basic overview of different types and classifications of meteorites. Then we have these things which I call meteorite relatives. The most common and perhaps best known of these are tektites. Tektites are actually splash material from meteorite impact. Again, the impact comes at such high speeds typically that the kinetic energy is turned into heat energy and actually melts the ground, the Earth's regolith, and throws it up in the atmosphere where it cools rapidly, forming glassy material. And so they have various shapes depending on how much got thrown up in the air, how fast they were going, and how far away they got. There are also these things called impactites, which is earth rock that was either created or modified by meteorite impact. And so, for example, I have a piece of a rock that was found in a crater in Germany called Nördlinger Ries. And this was interesting in that Gene Shoemaker was there in Germany, and he noticed that the cathedral there was built out of stone, and he recognized the stone as being of impact rock nature. And he said, where did the stone come from? And it turns out, we have this quarry that we got these stones from. And so he went to the quarry, and sure enough, it was full of this type of stone called Swavite. And so he said, you guys are in a quite large impact crater. And it turns out they were. And by the way, that crater also is associated with tektites, which fell not in Germany, but in the Czech Republic. And so those are moldavites, which are commonly used as jewelry as well, because they have a very distinctive green color. But impactites make sort of almost like a concrete looking type of rock. There is natural glass, and this is a melt product that results from an atmospheric meteorite explosion. And so I have one sample of that here. It's called Pica glass, which is from the Atacama Desert in northern Chile. And it's believed that an explosion of a comet, again, melted an air explosion, air burst, melted the dirt at this desert and created this natural glass. And there is impact sediment, which is sedimentary rock that contains evidence of a meteoritic impact. And I do have an example here of some sedimentary rock from the Botticoni Gorge in Gubbio, Italy. And that's where the Alvarez, Luis and his son were able to determine that this clay layer in between two layers of limestone contained about 1,000 times more of iridium than normal Earth rock does. Parts per million as opposed to parts per billion. So they said, since iridium is more common in metallic meteorites, something must have happened. And that happened to be about 65 million years ago. And so now it has an association with the extinction event at the end of the Cretaceous Paleogene eras. Used to be called Cretaceous Tertiary or KT boundary. So I've got a sample of that here as well. So how do these get here? Or at least get to a humble person like me who is a gatherer, not a hunter? Well, nomadic peoples know that there's a market for these things. So they look for anomalous stones in the desert. Then they're sold to middlemen in a marketplace, and that happens maybe more than once. And eventually they are sold to dealer collectors. So if there's thought to be a new or uncommon specimen, the main mass owner will send a sample to a lab for analysis and classification. The resulting information will then be submitted to the nomenclature committee of the Meteoritical Society for official naming and certification. And depending on the projected value, the owner may slice and dice the specimen for sale. And they use diamond-studded wire saws for that, for the most part. So, what is the value of these things? Well, like any commodity, it's based on supply and demand. And meteorite specimens are usually priced per gram. So, I'll just mention a few things about meteorite hunting. And if you are interested in hunting for meteorites, talk to me afterwards, because I can clue you into a hangout where you can actually talk to people who've done meteorite hunting in the United States here. But you have to be aware of quite a number of factors, including permissions, equipment, what's common, what's anomalous for the area that you're hunting in, what types of stones could look like meteorites, like slag, which is frequently assumed to be meteorites, local ownership laws, and perhaps transport and export regulations. So those are all the factors to keep in mind if you do decide to hunt for meteorites. Most of them are found in Antarctica, by the way, and that's a special case because Antarctic meteorites are by treaty to be used for research purposes only. But on the table, I do have an Antarctic meteorite that was collected before the treaty was signed. You're going to be buying meteorites. Well, you can go to a gem, mineral, or fossil show, like the ones they have here every November at George Mason. Although the meteorite dealers there are few and far between. Or you can go on the internet. Things to be aware of, though, is that there are some pricing attributes, things that will cause your meteorites to be more expensive than normal meteorites or others. So, for example, there are all these characteristics that will pump up the value of meteorites. But I say that if you are interested in acquiring them, I would suggest buying and reading a good meteorite book, like the Field Guide to Meteors and Meteorites. And I've got a copy of that here on the table. Select a few inexpensive meteorites to learn what you like, what you have an affinity for. And if you're online, look for sellers who display the IMCA membership logo. International Meteorite Collectors Association. It's an organization that operates sort of like the Good Housekeeping seal of approval for meteorites. And so you have to pass a number of gauntlets to become a member, and I became a member earlier this year. So I've got my number. And if you're buying meteorites, if the seller is offering a certificate of authenticity or COA, that's a really nice plus and something that's worth making sure you get. Got some samples of some relatively inexpensive meteorites that you can look up. Again, many of these are sold on eBay, and they have different types. I've got some that, the ones that you see that say octahedrite, those are the iron metallic ones there. HL, those are ordinary chondrites. I've got a relatively inexpensive palisite known as Sergio, and a eucrite, which is an achondrite from the asteroid Vesta, and that's a relatively inexpensive one as well. And I have samples of some of these on the table. And if you're looking to maybe spend a little more money, but buy relatively inexpensive carbonaceous chondrite like Allende, or a lunar like Oud 001, or a Martian one like Amgala 001, those are, again, for those types of meteorites, relatively inexpensive. What I also suggest is check the meteoritical database, which is sort of like the repository for all of the official, the details on all the official meteorites and approved meteorites before each purchase. And so here's what a page would look like. You essentially put the name of the meteorite you're looking for in the search, hit search, and hopefully it gets found there and is marked as official. Because potentially it could be marked as provisional, which means that it's been submitted, but it hasn't really been officially approved yet. So it's one of the things to check out. And if it's not in the table at all, it probably hasn't even been submitted. So it may not be official. I actually have a couple of unofficial and uncertified meteorites here that are I recently acquired, and it's because they're even more affordable than normal meteorites. Meteorite outreach. Well, it appeals to all ages. And every meteorite, I believe, tells a story. And it's a great activity when observing is not possible, like the weather during most of our activities these days. So what I recommend is using relatively large specimens that can tolerate relatively rough handling, especially from young children. And also I recommend not giving them more than one specimen at a time to handle. Because what do kids like to do when they have two meteorites together? They like to go and go punch, punch, crunch, which is generally not good for your specimens. Keep small, fragile, and or sharp-edged specimens in membrane boxes or Riker mounts. Riker mounts are these boxes that are held together by pins or held closed by pins. And you still have to keep an eye on them because a lot of kids will start to try and figure out how to try and open them. So again, just keep an eye on them. but that's where you can keep fragile, sharp-edged, or relatively small specimens. And bring flashlights and magnifying lenses to help visitors explore and examine. You can have a magnet available, but I tend to not to have the magnet out because its usage may lead to rough handling. Because magnets usually do one thing: either the kids will think that they're a hammer and start to bang on meteorites with it, or if there's enough metal, it'll pick up your sample. But as they twirl it around to show it to everybody, it may drop off and fall on the floor. So those are issues that I usually prefer not to deal with. But again, you can demonstrate the magnetic properties of meteorites. Don't display more meteor specimens than you can monitor. And that's just a caution there. And display basic information about all your specimens. And encourage your audience members to take selfies with meteorites. You want this to be a good, positive experience that they'll remember. And you'll have a better chance of remembering something if you have a nice selfie with it. When I'm running the meteorite station at the Udvar-Hazy Center, by the way, as a volunteer with the National Air and Space Museum, I like to set up near a sculpture of Neil Armstrong in his spacesuit. And I always have visitors say, take a selfie with Neil, he won't mind. So you want to mention basic meteorite information. And they're found all over the world. And most come from the asteroid belt. And that iron meteorites are from the cores of large asteroids. And stony meteorites tend to be the oldest unchanged objects that we'll ever encounter. And you want to keep up to date on the news of recent falls. Here's an animated GIF of a fall in a place called Charlottetown in, I think, Prince Edward Island that was captured on their doorbell camera with audio. So that's one of the first time that I think that's happened. And so fortunately, the homeowners weren't home at the time. They came back and said, who created this mess on our porch? And as they were scooping it up, a neighbor called and said, hey, I heard that there was a big explosion in the sky overhead. You might want to check out. And so they gathered up the pieces, sent it to a local college, and sure enough, turned out to be an ordinary chondrite. And it's officially cataloged as Charlottetown. So you can find it in the database. But it's there on video with the audio. And it came down so fast that there are only 2 frames in which you could actually see the falling meteorite. And be prepared to talk about some of the more popular or famous ones like Chicxulub, which is the one 65 million years ago that helped associated with the mass extinction event. And that one is from the Yucatan Peninsula. Barringer Meteor Crater and Chelyabinsk, which again, most people of a certain age have heard about and maybe even seen some of those videos. Public reactions are surprised at the weight density of iron meteorites. So, especially my Campo del Cielo here, I encourage you to pick it up and see if you have the same reaction. And then young children, of course, like to show how strong they are. And so monitor and control their handling of heavy specimens. Because if they fall on a body part, they'll leave a mark. Backlit palisite slices with translucent olivine crystals are always a big hit. And you frequently get authenticity questions like, are these real? And of course, you get terminology questions. What's the difference between a meteoroid and an asteroid? And questions on the frequency of falls. And some of them, some visitors actually have personal connections to meteorite falls. So that's always a real treat for both you as an outreach person and as the person you see the meteorite that they have a connection to. Even had one visitor at one point in time, especially with one of the spheres I have, get what they call a spiritual energy experience from that sphere. So don't be surprised. So frequently asked questions. How would someone know that a rock on the ground is a meteorite? That's a fairly common question and one that is really hard to answer specifically, other than you have to know what is common for the area that you're looking in to figure out what is anomalous. And also, there are certain attributes that they might have that will are good signs, but not really totally definitive. Like they're heavy for their size. They might have a fusion crust, that sort of thing. And so, but to really determine it, a piece of it would have to be sent to the lab for analysis. So how do they know that a meteorite is from the moon or from Mars? Well, the moon is fairly easy to explain. Apollo samples that were returned have been compared to some meteorites, and it's found that the meteorites are similarly, have a similar mineral ratios. So, for example, from the Mare, they're kind of basaltic and have certain ratios of like oxygen isotopes and other things that are more indicative of the moon rocks from Apollo samples. Others are made of more feldspathic or feldspar-like material. There's a mineral core called anorthite, which forms a rock called anorthosite, which is common in the lunar highlands. And again, those samples of Apollo returned rocks from the highlands compare very closely to some of these meteorites. Mars is a bit different of a story because, as far as I know, there's no samples that have been returned yet. And in fact, there's not even a really good plan to get samples back from our rover on the Martian surface, Perseverance. But what they can do is they can find glasses embedded in the Martian or in these asteroids that contain samples of gas that have been encapsulated when the impact occurred on the Martian surface. And so those gas samples, even though they're small, can be analyzed, and their O17 ratios are about twice what is normal here for the Earth. But it matches up very well with what our rovers and landers have measured on the Martian surface. So that's how we can figure out where a meteorite is from Mars. How much is that meteorite worth? Well, it's all over the map. And so really there are meteorites that are very inexpensive. You can get relatively small pieces of Campo del Cielo for very cheap money. Or you can get big pieces or very small pieces of very rare things for a lot of money. So it really depends. Do meteorites contain any elements not found on Earth? It's also a common question. And the answer is, since we here on Earth, Earth itself, and the asteroid belt all came out of the same solar nebula, all the elements that we see are in meteorites are the same as the ones we know here on Earth. What is different on Earth or in meteorites, though, are some of the minerals. And so some minerals are either very rare or unknown on Earth, but do occur in meteorites. And as a sidebar, there actually been some elements that were, or some minerals that were returned from some of the Apollo samples that were unknown on Earth too. In fact, one is called tranquilityite. It came from Tranquility Station, Tranquility Base on the Sea of Tranquility, and was thought to be unique to the moon until a few deposits were found here on Earth. And so I have one sample of tranquilityite from Australia, which is where it was found. But the name speaks to that it was first discovered in Apollo moon samples. So what's so special about meteorites? Well, they're the building blocks of planets. They tell us the age of the solar system. They can contain bits of other stars. The Allende meteorite, a carbonaceous chondrite, contains nanodiamonds, which are believed to have formed in supernova explosions from stars that lived and died long before our sun was born. So they don't even know how to date those. Their impacts change life on Earth. They give us information about asteroids, Mars, and the moon. And you can hold a visitor from outer space in your hand. So I've got some recommended reading here for general audiences. Tim Gregory's book is good, Meteorite: How Stones from Outer Space Made Our World. Again, if you really want to get into it, the Field Guide to Meteors and Meteorites is probably the best single volume. There is an e-magazine called Meteorite Times, which is free. There's also a dealer who does a lot of educational material, educational videos, Topher Spinato. And so you can check on his YouTube channel for a lot of videos that are geared towards beginners and explaining meteoritic stuff. There is a site for the meteorite picture of the day. And so they've got a new meteorite picture every day. And anyone can send decent photos of meteorites in and get published. I think I've got 33 images in there. I've got a little meteorite page. And the best thing about my meteorite page is there is a link not only to some vendors that I've done business with, but also I have a link to a document which is a glossary of meteoritic terms. And so that can be helpful to learn about the nomenclature associated with meteorites. And there is a weekly Zoom hangout for people who are really enthusiastic about meteorites. So if you are one of those people, either see me afterwards or send me an email saying meteorite hangout as the subject. I can send you a link with details on how you can get up to the Zoom session. So I'll end by saying it started with a gift, and it became a collection and made a difference in my life and just maybe a few others. Thank you.
That was really great. Do we have any questions online? Well, first you're in the group. Do we have any questions?
George.
Has meteorites fallen on the Earth changed composition in any way of the surface layers of the Earth? I mean, most of the iron sunk to the core of the Earth when it was formed, right?
Right.
So has it metered all these iron meteorites? Have they actually sort of boosted the composition of iron and other layers of the Earth? Or
So the question is, have the meteorite falls changed the composition of the crust of the Earth? Essentially, that is what we.
Or is that just
Yeah. I don't have an answer for that. Probably the answer is yes. I mean, because there were periods that are where we were more heavily bombarded than we are now. There's what was called the early heavy bombardment and the late heavy bombardment. There are even questions and it's active research as to whether meteorites and comets brought much of the water that we see here on Earth. I think those are all active areas of research. Paul.
I'm just curious, in the last, I don't know, 50 or 100 or 200 years, has anyone been killed by a meteorite?
Depends how you define anyone. And so there are maybe a couple of people that have been hit by meteorites. The one that's most famous was 1954 in a place called Sylacauga, Alabama. And a meteorite went through the roof of a house, bounced off a bureau, and sort of brushed a woman and left her with a nasty bruise. It was on the cover of Life magazine back then, because it was a big to-do. But that's really the only documented, well-documented instance of someone being hit by a meteorite. This is Hodges. But there are also, I have a sample here of a piece of a meteorite called Valera, which fell in 1972 in Venezuela. Overnight it fell, and when the farmer whose land it fell on went out to see what was, if anything had happened, he found this, semi-buried big stone near a cow of his, which had died as a result of the hit. So that's known as the cow killer, if you will. And so again, that's one of the things that you'll pay a premium price for. But as far as I know, not too many, individuals, creatures have been hit. There are people who collect those specifically that have hit stuff on the Earth, though. Those are called hammers. And so I've got a piece of Peekskill here, which went through the trunk of a car in Peekskill in 1992, and Peekskill, New York. And so that's one of the more famous hammers, if you will. And you can get a chance to see that here. So.
You don't recommend buying meteor insurance?
Well, it really depends, because it's probably a very low risk. Probably if you buy lightning insurance too, you could be about in the same category there. For example, in Hopewell Township, New Jersey, a couple of years ago, one went through the roof of a house. And so they found it, gone through, punched a hole in their roof and left a bad dent in their wooden floor, on the second floor of their house there. And so that happens. And even there was one locally here too. In fact, in Morton, one went through the ceiling of a dentist's office. And so that one you can find in a natural history museum and Smithsonian Natural History Museum. And they even also have in their meteorite room, they actually have the ceiling tile that it went through.
Don't those sell for a lot of money afterwards? I mean,
Oh, they can, and that's why if you, one of the things that will bump up the price of meteorites are recent falls, because they get a lot of attention and they're very fresh. But see, scientists like recent falls too, because the fresher they are, the less contaminated they get by our atmosphere. Yes.
I was curious, how is obsidian different than techites? Is it just composition or is it formation?
Formation.
Okay.
Obsidian is, obsidian is largely basaltic. Okay. And whereas tektites are whatever the regolith is, melted up.
Okay.
So that's primarily the difference.
Okay. Got it.
Not being a volcanologist, though, I can't give you anything more detailed than that.
What is the largest meteorite ever discovered?
That's the Hova meteorite, which is estimated, because most of it's still in the ground, estimated to be about 60 tons. So that's in Namibia. The biggest meteorite fall, the ones that has the pieces that collectively weigh the most, is Campo del Cielo. That's in northern Argentina in Chaco County. And that's why there's so much of that on the market, and why it's very small pieces of that are very inexpensive. But there's quite a number of metric tons of that stuff that's available.
Wow.
There are pieces that weigh more than 300 tons, by the way.
Do we have any questions online? I've been trying to watch. I haven't
None
really.
yet.
I don't think it's quite up.
No hand
Maybe
raises.
we do.
Paul Jacobs raised his hand.
Okay.
Yeah, I was wondering how do you tell the age of a meteorite? What do they do to determine that?
Okay, the question of age determination of meteorites. Excellent. Because those who know about carbon dating know that that is really only for maybe tens of thousands of years at the most. And so for things that are billions of years old, it's either like strontium rubidium dating or uranium lead dating or lead dating. And so those are, what you do is you measure the various ratios in various parts of the sample, you plot them on graphs, and where it crosses one of the axes, that's the date of your sample.
So a lot of these datings are using
Radiometric dating, yeah.
Got it.
And you can also, there are other techniques that they can use to determine, for example, how long something might have been out in space. For example, if it's blasted off the moon or Mars, by looking at certain isotopes of certain elements, they can figure out cosmic ray exposure times. And that gives them a sort of a measure of how long it's been sitting out in the solar system before landing on Earth.
You got the compliment on your tie from the.
Oh, thank you. Actually, I had this made. There's an outfit called Zazzle.com, and these are meteorites in my collection.
Oh, wow, very nice. Anyone else online or here? Well, this is a very interesting area. Thank you very much. You're obviously very good at what you do, and we appreciate you taking the time to do it. I wish more of you were here in person to see all the neat stuff he's got to show you. I would mention that the Air and Space, at National History at the Meteorite Hall, where we do sleepovers 7 times a year, times now 15 years. We do a lot of meteorites, and but the point is, the kids really love it. And if you want to see a really big one, we have some big nickel iron ones that are about this big. And I tell the kids, you can't hurt it, talk to it, do whatever you want to it. Because they're out there for that, and you can't really hurt it. But anyway, kids do all sorts of weird stuff with it. And but anyway, there's a lot of very interesting stuff that's there, and some of it's not out front, and you got to sometimes ask. I think they put up the one about the went through the ceiling.
Yeah, Lord, yeah.
But at different times and places, different curators put up different stuff. But there's a lot of neat stuff to see it. It's not in air and space, is what I was going to say. Just a couple of small samples. Big stuff is actually over in natural history. So, but anyway, if you don't know that, you would be wandering around in air and space. But we really appreciate Cal taking the time to do this. He's really great at all the things we go, all the different activities we do, like Astronomy Day and Space Day and this, that, and the other. I do also want to notice, thank you to two folks that came in from Mason Astronomy Club, or maybe Mason.
I'm just a part of Mason, but
Okay,
yeah,
well, we got bad information from, but anyway, but that's what we appreciate.
but
your
also
time.
astronomy. Yeah,
Yeah,
that's how I heard about it.
Okay, we're glad to have you. Thank you. Did you have anything else, sir?
No, that's it. Thank you very
Okay, well,
much.
thank you all very much. And so we'll start, we'll let the folks look things here in person, and we're all gonna go look at the observatory if you were here. So hopefully we'll have more people next time. We'll be May 4th. We'll be starting at 4 o'clock. And if that's no other questions or comments, we'll shut down for the night on we got one here or not? Okay, well, we're dropping. Thank you very much. Have a good evening.